Good morning to all of you. Welcome you guys. Welcome you all. Very good morning to everybody. I think we are live. First of all, do comment करके बोलिए now is audio videos clear to everybody? Right. First of all, a great news to all the aspirants who are seriously preparing for GATE 2027-2028 के लिए. So first of all, you can have a look at now. Now the Unacademy subscription that is just 8,999 only. इसके साथ आपको बढ़िया से बढ़िया ऑफर भी मिलेगा. दैट इज व्हाट हैज बीन अ फ्लैट 60% ऑफ डिस्काउंट एंड सो सब्सक्रिप्शन प्लस फ्री एक्सटेंशन भी आपको मिलेगा. द ऑफर इज वैलिड अप टू 11th June only. Try to utilize this opportunity before it going to expire, and you can use the code of PV Reddy and to avail these opportunities. Use the code of PV Reddy and to avail these opportunities. The price going to hike soon. Utilize the opportunity before it going to expire. Now, and another great thing is Unacademy free special class festival, and which is from 9th to 11th. 9th to 11th. So with this, you can get to know the chart live with the top educators, attempt interactive polls, get your doubts are cleared. Free live class festival. Enroll for it immediately. So with this, you will get to know how the Unacademy platform, you can able to explore the Unacademy platform with this special class festival without paying any single rupee also. We starting on new batches. We are starting from 12th June onwards, Naya batches, and we are starting the digital and EMF free starting. You can find the top educators team. आपको एक साथ मिलेगा. राइट फ्रॉम 12th June onwards नया बैच शुरू होने वाला पर 2028 के लिए भी. These are the Unacademy GATE 2026 rankers. These are only from EC and electricals get these many rankers. From that you can estimate now here. These are the top 100 में इतना ranks Unacademy से आया. And many more rankers are there. Still counting. ESC 2025 का rankers. Yes. And we do offer the 2 subscription, plus subscription and iconic subscription. Plus में आपको क्या चीज मिलेगा? Top educators classes, live doubts, evaluated test series, structured courses, live test, unlimited access. And then iconic में personal coach भी मिलेगा and physical notes भी आपको मिलेगा. Right. Next. Can book your time slot according to time convenience. Interact with your mentor. We can start the serious preparation with the Unacademy to achieve your dream goals and will provide you the best knowledge for you all. चलिए आज का सेशन हम शुरू करेगा. Last class, how many problems we have completed? You can have a look at. So, how many problems we have finished? So many problems are there. Right, 185 we have finished. Right. Next. In the given circuit, the potential at the point B is. The potential at the point B is. Yeah, you can tell me now here. B with respect to A. So that means we need to find what, tell me now? VB minus VA. Now, so see this part of circuit is given as, and this is the voltage and having some resistance also given, and this is the point B given, and this is the point A given. So this is 2, and here this is 6 volts, and this is 2 ohms, and here this current is 2 amperes. Right. Now you can tell me now here. So I will call this point. So this is this voltage which we can see now VA, and this point which will be a positive, and here we have somewhere we have ground is there, and this point which will be a this point B, and here this is the positive, and here this is the ground, and this is what we can say now VB, and this is VA. Now these two grounds are same only now. Now we can write the KVL inside the loop now here. So tell me what we'll get now here. So we are starting here now. So that is now this voltage which is equal to plus 4 minus 6 plus 4 plus VA minus VB equal to 0. So take the VA minus VB to other side, 8. So this is 8 minus 6, which is equal to what? Tell me now. VB minus VA. So from this we can write VB minus VA, which is equal to how much now? 2 volts. Next one. In the circuit, the cells are having negligible resistance. If galvanometer shows null deflections, then the value of V is. Null deflection means what? Tell me. Yes. Here this is a ground first of all. Null deflection means what? Tell me now here. Whatever the potential here is the potential which is V. So if I call this potential is V1, this potential is V2. And for the null deflection, V1 and V2 must be same. There is no flow of current. So here this current must be 0, means what we can say, both the potentials are same. Okay. For null deflections, the condition is what? Tell me. For null deflections, V1 equal to V2. And how much is V2 value given as, which is given as V. So we need to get the V1 value, get the V1. This voltage is V1 now. So how much is V1 value? So this voltage 100 by 600, 100 by 600 into 12. So this value 6 now here, this value 2. So how much the V1 value, which is equal to 2 volts. That means V1 which is equal to V2. V1 is 2, that is equal to V2. So that means how much now? 2 volts for null deflections. Next one. When a resistance R1 is connected across a cell, the current is I1. If the resistance R1 is replaced by R2, the current is I2. Then the internal resistance of the cell is. And we have the source having the internal resistance is R. Now, so this is connected to a some voltage of V. Now, this is connected to a resistance is given. How much the resistance is given, which is given as R1. Now they are calling this current which is equal to I1. So how much is I1 value? that is given as V by R plus R1. When it is replaced with another resistor replaced by R2, the current which is equal to I2, they given it as V by R plus R. Now they ask him to find the internal resistance, they ask him to find. Let's get it now here. V same now both the cases, so V from the first equation we can say now V is equal to R plus R1 into I1 and the here. So this is from the second equation V which is equal to what will be now R plus R2 into I2. Now we can say that two equations we can equate now. That is R plus R1 into I1 equal to R plus R2 into I2. So multiply, simplify now. R into I1 plus R1 into I1 which is equal to R into I2 plus R2 into I2. Now, so we need to get R now smaller. I can bring this is R1 I1 minus I2 and which is equal to what we can say now here R2 I2 minus R1 I1. So from this we can get this value of small r now, which is equal to what we'll get now here R2 I2 minus R1 I1 by that is I1 minus I2. So what's the option you can see? R2 I2, yes, so option D. Next one. In the given part of the circuit, the potential at point B is 0. Then the potential at A and C are respectively. Potential at point B is 0. Okay. Then they ask him to find what, tell me now. Potential at A and C is. Now here, so there is a flow of current. So then this is positive, this is negative. This is 1.5 volts. Now we can write it as what tell me now this current. It should be from A and B. So this is 1 is equal to VA minus VB by 1.5. VA minus VB by 1.5. So this is, we have this is 1.5 which is equal to VA minus VB value 0. So that's why VA equal to how much now? 1.5 volts. Next. Now the same kind will flow here also now. Same kind is flowing here also. So this I G is equal to VB plus 2 minus VC by 2.5. I value 1, so this is 1 is equal to VB value given as 0 plus 2 minus VC by 2.5. So that is 2.5, which is equal to 2 minus VC. So the VC equal to, see, 0, no, 2 minus 2.5, which is equal to minus 0.5. Option D. Next, in the given figure, V1 is V, V2 equal to alpha into V. R1 given, R2 given, alpha, beta, gamma are positive real numbers. The values of current I is. We'll take this as a ground and this voltage. This is also V2. I think there is small correction in the question, I think so. Let me check it now here. What the correction might be. 190. No, correct only, no correction. V1, yes, correct only. Yeah, we need this current only. Fine. V2, V2, so two V2s, yes. Fine, correct only. Yeah, but it will be a little lengthy, will come, fine. Yeah. Right, so what I can do here, this current to get now. So here, this one, if we apply the source transformation, yes, to R1. So this current will commit as what, tell me now? So that is V1 by 2R1, and the current is upward directions, and the resistance which will be a 2R1. We apply the source transformation for this also, that is V2 by R2, and the current is upward directions, and this resistance is R2. I will combine these two. So we'll commit as V1 by 2R1 plus V2 by R2. Now these two resistors are in parallel. We'll commit as what we can say now 2R1 into R2 by. So this is 2R1 plus R2. R1 2R1 plus R2. R1 R2 by R1 plus R2. Now thereafter we can again apply the source transformation. Then here, okay, we can place now here V1 is V by 2R1 plus V2 is equal to alpha V by R2 is what, tell me now? R2 is R1, which is given as beta into R. This is given as gamma into R. So if we have taken this as V by R common, then we'll commit as 1 by beta plus alpha by gamma. So that is V by R into what tell me now? Gamma plus alpha by, that is beta into gamma. Okay. Now this resistance is 2 into R1, that is beta into R. Beta into R, this is R2, gamma into R by 2R1. So that means, okay, 2 is missing here, 2 is there here. Then it will come it as 2 alpha. Yes, that is 2 into R1 is beta into R plus R2 is gamma into R. So will come, R will get cancelled to 2 beta gamma into R by, that is 2 beta plus gamma. Now again we write the current source now here, this term, and how much this value of current will come? So this value, so I value which will come to be a V by, no, this is the current only now. We'll get this voltage now here. Yes, the voltage will come to be a what terminal V by R into, this is 2 alpha plus gamma by 2 beta gamma into, yes, 2 beta gamma R by 2 beta plus gamma. So this is Vx, which is equal to 2 beta gamma will get cancelled. This R will get cancelled. So this is V into 2 alpha plus gamma by, this is 2 beta plus gamma. This is the Vx. And the resistance will come in a series. And thereafter, this is V into 2 alpha plus gamma. V into 2 alpha plus gamma by 2 beta plus gamma. Beta plus gamma. The resistance is 2 beta gamma R. 2 beta gamma R by 2 beta plus gamma. 2 beta plus gamma. And the remaining part of circuit is as it is. R1, that is 2R1. So we can say this as 2R1. And this is V2. V2 equal to given now something gamma into V. Sorry, alpha into V now, alpha into V. That is alpha into V. So we need this current we need now, I. So you can tell me now here how much is I. Okay, if you find this current now, if I call this is Ix, so this Ix is equal to, that is V into 2 alpha plus gamma by, that is 2 beta plus gamma minus alpha V by sum, that is 2 beta gamma R by 2 beta plus gamma plus 2 R1. R1 equal to beta into R. Okay, beta into R. Baapre. So much of simplifications. Now simplify. You will come the options. Check for the things now. Which option may come? Very lengthy thing now. So this is V into 2 alpha plus gamma minus 2 alpha beta minus alpha gamma by 2 beta gamma R plus gamma. V. So this value will becomes 2 alpha plus gamma minus 2 alpha beta minus alpha gamma by yes 2 beta squared gamma plus what, yeah, so we're getting so much different answers. Check this thing, what will come. Any mistake anywhere we did? Options are not matching here. We're not getting any option. 2 beta. Something we have missed, I think so. Fine. We'll do this thing again. Let me continue the remaining things. Okay, the value of current through 5 ohm resistor. Now the given circuit is the value of current through 5 ohm resistor. Now, so if we have taken this as a ground, we have considered. Okay, this is directly connected here now. Mm. We have taken we have taken this as a ground, and this voltage which we have taken it as Vx. So tell me now the nodal equations. So this is Vx minus 5 by 4 plus Vx by 8 plus Vx minus 3 by 5 equal to 0. Now simplify it. So we'll get the Vx value, that is 1 by 4 plus 1 by 8 plus 1 by 5, and which is equal to what you tell me now, 5 by 4 plus 3 by 8. So what is the LCM? We'll take LCM, which is equal to 40. So this is 10 plus 5 plus 8, and this 3 by 5 now. Okay, so this is 20 LCM now. So the LCM, which is equal to 20. So this is 25 plus 12. This is 2. So this is Vx, which will come to be a, so 13 by 2, 37. So Vx value will come it as 2 into 37 by 13. So you can simplify Ix. So this Ix is equal to Vx minus 3 by 5. I can simplify now. This is how much if we simplify. This is 5.69 minus 3 by 5. 7 by 13. I can check this option now. Vx minus 5 by 4, Vx by 8, Vx minus 3 by 5. Correct only now? So why we are getting something different answers? Options are not matching. Vx minus 5 by 4, Vx by 8, Vx minus 3 by 5. So we have taken Vx common here. This is 1 by 4 plus 1 by 8 plus 1 by 5, and which is equal to 5 by 4 plus 3 by 5. Now simplify. So Vx 40 is LCM. This is 10, and this is 8 5s, 5 8s, and this value 20 LCM. This is 25 plus 12 by 20. This value 2. So we got the Vx value. From this we can get Ix. And you can simplify, do verify. The procedure is this thing. Okay. Yeah. Fine. Okay, that's it for today.